Many people approach a large language model the same way they approach a search engine or a basic smart speaker. They type in a quick question, hit enter, and expect a perfect answer. When the output comes back as a generic, hallucinated, or unhelpful mess, the immediate reaction is usually to blame the machine. It is easy to assume the underlying model lacks the intelligence to understand the request. Prompts represent something far more structured than a search query. They function as a complete framework, a collection of instructions, boundaries, and specific context that directs the model's focus. The machine is failing because it lacks a human-provided framework. Interacting with these models is an engineering task, requiring iterative refinement rather than a simple request. To see how this failure happens in practice, let's give an AI a complex, multi-step business analysis problem. We want it to evaluate a quarterly sales report, identify growth opportunities, and assess potential risks. If we just paste the raw data and ask for an analysis, we're using a zero-shot prompt. Zero-shot prompting means providing no examples or specific instructions, leaving the model to figure things out entirely on its own. The result is an immediate, disorganized failure. The generated text reads like a generic template. It invents speculative data points that aren't in the original report, and it completely lacks a logical structure to connect the sales figures to actual business strategies. We have a broken, useless output. How do we build a systematic, human-driven feedback loop to rescue this text and force the AI to produce a highly accurate analysis? The first step to fixing our failed prompt is giving the AI a specific identity to anchor its response. We need to tell it exactly who is analyzing this data. We do this through role-based prompting. This technique involves explicitly instructing the AI to act as a particular professional, in this case, an expert financial advisor. This guides the AI to draw on specific knowledge and communication styles associated with that profession. With the role assigned, the output immediately improves. The tone shifts from generic text to professional analysis, and the perspective aligns with someone evaluating financial risk and reward. Assigning a role establishes the right context, but the resulting document is still dangerously cluttered. The AI is eager to play the part of a financial advisor, filling the page with dense, unfocused observations. Our response is now trapped in its assigned persona. Because it is trying so hard to sound like a financial advisor, it overcompensates, burying the actual insights under heavy industry jargon and unnecessary tangents. To clean this up, we use negative prompting. This is the practice of explicitly telling a generative model what to avoid producing, setting firm boundaries on its output. We update our instructions, specifically commanding the model to avoid making speculative claims about future quarters and to completely exclude industry jargon. The second iteration yields a highly refined document. The tangents disappear, the vocabulary simplifies, and the analysis becomes clean. Telling an AI exactly what not to do is just as critical to achieving a usable result as telling it what to do.
The tone and format are now perfect, but a closer look at the text reveals a serious problem. The AI has miscalculated the projected growth margins, exposing a flaw in its core logic. The logical next step to fix this math is few-shot prompting. This method provides the AI with a few correctly solved examples within the prompt itself, so the model can learn the pattern and mimic the desired structure. But for reasoning-heavy tasks, providing examples can actually backfire. The AI replicates the exact visual structure of our provided examples, but ends up inserting the wrong logic and mathematical variables into the new problem, degrading the overall performance. Research shows that adding examples for complex puzzles often biases the model. Instead of engaging in deep reasoning to solve the specific numbers in front of it, the model lazily copies the surface patterns of the examples we provided. Mimicking examples is not enough for complex problem solving. We must force the AI to actively generate its own logical path from scratch. Large language models gain a massive boost in accuracy through a method called chain of thought prompting. Chain of thought prompting involves instructing the model to think step by step, forcing the AI to output intermediate reasoning steps before its final answer. This space allows the model to verify its work, identify logical errors, and self-correct along the way. We can see this in action on the Strategy QA benchmark. When asked if it is plausible that Malcolm Brogdon banked a shot in, the model uses step-by-step logic to determine that Brogdon is a basketball player. Banking the shot in is part of basketball, and therefore the event is plausible. Applying this exact chain of thought process to our business analysis, the AI evaluates each sales figure sequentially. The math is corrected, the logic holds, and we receive a final output that proves this method forces the model to engage its underlying logic rather than just predicting the next word. Stepping back from our sales report, we can look at the overall transformation we just orchestrated. We took a chaotic, hallucinated output and carefully engineered it into a precise, expert-level document. This entire iterative process can be standardized using the CLEAR framework. CLEAR stands for concise, logical, explicit, adaptive, and reflective. Explicit with our role assignments, logical with our step-by-step reasoning, and adaptive with our negative constraints. We guided the machine away from generic failure and toward a highly targeted solution. Prompt engineering is never a one-off command. It is a continuous, reflective, and adaptive conversation between a human and a machine. Generative AI operates best as an extension of human thinking, rather than a total replacement for it. Accessing a model's most complex capabilities requires incredibly rigorous, structured human direction. Raw computing power operates in a vacuum. It is useless without a human orchestrator to explicitly guide that power into a specific, useful structure. Language models will continue to grow smarter and faster, but the ultimate limiting factor to their capability will always be the clarity of the instructions we give them.
AI isn't just another tool. It's an intelligence system for your dealership. Learn how at autoagentic.ai.
Or get your free copy of the Automotive Playbook for rebuilding organizations around AI. Also at autoagentic.ai